All right, so today we are going to be looking at delve into the software part of this whole thing. Let me just flash the some of the slides from last week, and we'll take it from there before we enter this. So I know last week we talked about the computer being made up of hardware and software. But when you come to the software, we need to actually classify them. Okay, so the whole hardware, is just to help you to do a particular task. And most of those tasks are just software based. I don't know any task that is strictly hardware. Even if you are controlling a drone, which is a hardware, there will be a software. You cannot just control the drone directly unless you are using something like RC, you know, um, RC remote control. There is this small vehicles, toys that you can use, transmitter and everything to control. So you don't really. But at the end of the day, if you check what is running there, usually is a chip. So somehow, even though you don't see it on the screen, it's still software. So software is the part that you cannot touch. Hardware are your devices, your input, output, your mouse, your keyboard, your laptop, and everything, motherboard, all those things you can touch. You simply classify them out as hardware. Just cannot touch, simply classify as software. So when you come to software, the two categories I've talked about is system software and application. Okay, let me just go to the next slide. So these are the two major classification of software. The system software is software that comes with the system. This is where we're going to start of our this thing. Remember, this second one is a application and operation. So we're not going to start doing one or two things and understanding how the system works. So the goal of this software is it is designed actually to provide a platform for execution of computer program. That's the main software of the computer. That's why it's even called system software. So if you don't want to, kind of memorize anything, it's just the software of the system. Whatever system you are using, are you using cloud? Are you using your tablets? Are you using your laptop? Are you using a desktop? Any software that allows you to manipulate, put it up, put it on, install, that is actually the software of that system. So please let us go beyond just normal computers. What of your Mercedes Benz? Okay. What of your home automation? So when you go to a car that has all this dashboard, that car is not using Windows, right? So I want to show you, I want to equally inform you that there are some other systems that have their own operations, So if Mercedes Benz wants to employ someone as a software engineer, they are not employing you to come and be using Microsoft, when you boot, you see Windows. No, you're going to see Toyota logo. So you need to understand to how to write code to that level, like C. I think they normally use C because I've shown you. I'm going to show you high level, low level, and everything. So you need to understand how to write the core, very, very basic code that are not really, really high levels. There are some mid-level languages and all that. So that's the level that you can actually start writing OS. You cannot be doing all those things with just Python and all that. There are high-level languages that even run on the system operation. So I want us to begin to naturally understand these things without really forcing us to think so much. So even bikes these days, there are some smart bikes, you come in, the logo will come out and everything. We see some bikes that have a basic turn to left, turn to right, and everything. So, for those of us that don't know, there are a lot of companies that will die to take you to work on their OS, improve it, or even build a new one. I'm not sure the OS that the Benz of 2014 is using is the same OS that the Benz of 2025 is using. So there is job, and the truth is that these kind of people are becoming scarce, and they will not stop building. I'm sure they're going to want to improve on their OS, probably Toyota, Ferrari, and all those kind of things. You see the new vehicles that you see today. it is OS. So please, when you talk about OS, don't narrow it down to your Windows and all that. Okay. So most of those things you have the driver. So when you talk about computer, driver, you talk about graphics card, your of your the way your graphics displays depends on the driver that is installed. Okay, there's what they call graphics card. Some people know NVIDIA and so on and so forth. All these things we are going to talk about it. So OS is actually is the system that connects to the hardware. That's the system that connects. That's why it's called system software. So sometimes people mistake OS as system software. Yeah, OS is a kind of system software. These are where you begin to clarify some of these misconceptions. There are other system softwares that are not OS. We are going to talk about it. So OS means operating system. Okay. Just like operating system is the system that understands the controls, manages all the hardware like bus. I mentioned bus how data flow from one part of the computer to another part using the bus. There's communication bus, there's data bus, address bus, all those things. Okay, it is this system software that is involved, right? Let's go to the second one. They say driver. Driver is not the one, it's not like Uber driver or something. So in computer term, whenever you hear driver, because you might be hearing it for the first time, or you might have heard about it before, or probably you heard about it and you be like, what do they mean? So when you buy a new system, right? If you actually install your OS, right? The OS is basic. That OS will equally need, to update or install drivers. The drivers are the things that help you to work with. First of all, let's go to the peripherals. If you don't have a driver for a particular printer, even if you connect the code of that printer to your system, that peripheral is useless. If you have a mouse, whether wireless mouse or wired mouse, if the driver is not updated, the mouse will malfunction. You have a flash drive, but you can see drive, that name is drive. So the flash drive equally connects to a driver, and then when it is plugged into the system, what you see on the screen is it shows you a notification that something has actually entered the system. Okay, that's the drive. So there are different things, drivers are mostly used for all this input output stuff. So you now have the drivers for your um like your vehicle now. You can begin to imagine, like pressure sensor in your tire. So why do you think probably when you enter your car and the tire is kind of deflated a bit, like it is not the pressure is not optimal, you are going to see the this thing on the dashboard. When the oil is low, you are going to see indicator on the dashboard. When what else? Fuel, yeah, fuel gauge. When temperature, so speedometer. So what do you see that you see is why do you think it is comfortable for you to just sit down and watch all these things at the dashboard? It's drivers, because the OS will have a driver that will be connected to some of these things so that you can actually interact with it. So I want people to understand the driver goes beyond the one that you know. So that's the thing. Now there are other things, that's why I put them in purple there. You can't really call them applications. Some people, school of thought, they believe that they are a classification of their own. Some people believe equally they are as part of systems also. It's called utilities. Utilities are not necessarily drivers, right? Various systems, they utilize different configurations, right? When you hear something like antivirus, antivirus is a software that protects your system from attack, right? That particular antivirus, you can't call it an operating system. You can't call it a driver. So some of these utilities, they are there in the system. They are not used for, like, I'm going to come to application software very soon. So there are some other, so they are in between. So the reason why I'm saying this thing is that you don't have to like have a rigid understanding about this thing, just know what the utilities are, right? Like system performance, you have your system performance reading how the CPU is performing, the disk, how the disk is performing, if there are underground processes that is running at the background and all that. So these are the kind of things that utilities do. Okay, so now let us come to applications of it. Everybody knows, nobody, even if you are hearing it for the first time, you already know it. Application software is the one everybody uses. In your mobile app, sorry, your mobile phone, you have something like app. That name came from application. So I downloaded this app, and then it's simply application. If you come to your desktop, laptop, and everything, you see a lot of software. So you can see app, software, program. Sometimes these things can be used interchangeably. So I don't want us to fixate. I just want you to understand what they mean. Okay? A software is the same thing as an app. You understand? So it's just a matter of semantics. So because you are using a mobile phone, they have actually devised that and adopted it as a term for mobile phone. So app, mobile app, web app. Okay, it means application. That's the truth. So application, they are designed to perform specific tasks. Okay, why is it defined like that? Okay, because it is the end user that uses it. Now, what does end user want? That's the task that you want to perform. If I want to watch a movie, I'm not going to use Excel. So you know that VLC is a software, and that particular software is used to what? Watch movies. That's why they say it is designed to perform specific tasks. Excel, in the other hand, is not used to watch movie, but it's used to do some kind of data analysis, do some calculation and everything. So that Excel is built for that. Okay. Then Microsoft Word, okay, is not going to have, you cannot write equation to calculate. Even if you draw a table, that table is not automatically, used for calculations. If you want to do calculation, go to Excel. Microsoft Word is, of course, you can build table, which is a static table. You can equally use it for developing, mainly for developing documents like Word documents and everything. So you can see the functions here. It is not exhaustive. You just have to drop some of them because you don't need to overthink it. Productivity software, things like spreadsheets, whether it is Google Sheet or Microsoft, and we are going to do some of these things practical here in this particular. That's the idea of applications and operations. You're going to use them to perform different things. When it comes to media, right? You have things like a VLC. There are some software that used to edit pictures. There are some software used to edit videos. For instance, Adobe Premiere Pro is not used for calculating or doing accounting. It is used for what? Editing videos. Some of you have used CapCut. Okay. We have things like Photoshop, CorelDRAW, and all that, PowerPoint, and so on and so forth. They are equally business software. Okay. Some of them, they are referred to as enterprise resource planning or customer relationship management. Enterprise means, I'll give you an example, right? If a company is managing different things, like a very large company, it is called enterprise most of the time because the management system takes care of everything and tries to make the business operations easy. So when you hear enterprise means they are building it for a business. Okay, so you might be why I'm kind of saying this thing is that tomorrow they might bring you into your UI designer. Say, okay, please, I want to build an enterprise system. Just remember that Lauren says something about enterprise, and that is how you can build this your tech career seamlessly. But not when they talk about enterprise software, you are still guessing what it is. Okay. So most of them is enterprise resource planning. Is like, let me give you an example. If I am running an oil and gas company, enterprise resource planning is like a central place where I plan everything. Human resources, safety, plan for environmental, you plan for accounting, you plan for journeyman because people are going to be flying chopper offshore and onshore. You're going to be planning for even food, those that are offshore. If you don't have all these things sorted out, one day people will go offshore and they won't find food. And remember, these people are eating from morning till night, every single day, every single year. If they give you that particular job alone, it will take care of what of those that are cleaning, do that. So you come to an environment, everything is working. Have you asked yourself, why is that thing working? It's because they have an enter. If you want to visit any company, now do you know you have to book in first? When you book in, the security people on the gate know, okay, this person is expecting this person, this person. When you go to the gate, they will give you a tag. There's a process for everything because it is what they call enterprise resource. It is an enterprise then that are using the software to plan all their resources that is available to them, both human and material. Okay, so whenever you hear enterprise, make sure that you are likely going to be developing a management system. Okay. Then you have other things like web browsers, of course, Mozilla Firefox. This thing is not exhaustive. Your bank app is a software, okay, because you cannot really touch the bank app, but you can touch the buttons, do transaction and everything. The engine that is running it is soft engine because it is a code that is developed. So when they talk about engine, most of the time it's not really the machine as you know it, like the moving parts, crankshaft and everything. So sometimes the code that you write is called an engine that can drive something. So in a nutshell, application are things that we use. Everybody uses application, no matter how many apps you have downloaded on your phone. Use it. Sometimes in the system, you need to install the software for it to run it because they'll give you an installation file. We're going to talk about file system very soon. So having said that, the software you can see, in addition to the three I've mentioned, like the operating system, the drivers, these are system software. You can see other people have different schools of thought. I'm showing these things so that you know, oh, Lauren did not say this one. No, I have to just mention everything because when they tell you what is a system software, you just crap is operating system, nothing else. I have mentioned drivers, right? For instance, in the operating, of course, you see the operating system, Windows, Mac OS, Linux distribution, and these are the ones that are used in our typical laptop. But remember, I have mentioned things like cars. Everybody have their own operating system. So don't narrow your mind to this other one. Then let's all go to drivers. Drivers are, you can have graphics driver. I've told you to kind of manipulate some of the things that are peripheral to the system. Graphics like NVIDIA, AMD, Intel, these are the common ones. You have your printers as well, audio and all that. Utilities, you can see disk management utilities like disk cleanup, and all that, antivirus, the software used to back up your files and everything. Now, this is the tool that you've not heard, firmware. Now, firmware, you're going to have like your BIOS. Meanwhile, what is BIOS? Let me even mention it here. BIOS simply means basic input output system, right? So BIOS, you hear all these things, you don't know what it means. So that is actually when you we are going to talk about booting very soon, don't worry. I'm going to go. So basic input output system, okay. Um, you have device firmware. Firmware enable the device to work together. It can be wireless. So one of the things that firmware does is those that are going to be doing DevOps and those that are going to be going into IoT. This term firmware is going to come up later in your career. Firmware, for instance, if I have a camera in my home and that camera is wireless, ask yourself a question. Assuming that camera is wireless and I have like a phone that has a software that is connected to that camera in such a way that I can be looking at some people have those kind of things. They'll be watching their house even when they are at work. Okay. Now, do you know what is happening is that there is a software, okay, and then there is equally a hardware in that camera. That camera will have something that I'm not going to mention the name of that thing until we come to the specific area. We're going to talk about communication protocols, but I don't want to confuse anybody. So the camera will have something, just accept it that way. It will have something that enables it to transmit okay, whatever video it is taking in the house to dial your phone, right? So that camera is now communicating with you over the internet. So you now have what we call Internet of Things. Before now, it is human beings that actually interact with connectivity. It's human beings that interact with the web browser through which we send email, browse, search engine and all that. But right now, things are beginning to use the internet, and that's why they call it Internet of Things. Meaning that objects now, devices, sensors can actually communicate over the internet. So when you have these devices, back to this, I don't want to deviate into Internet of Things, back to firmware. You need a firmware, like a program that will be able to manage the operations of that device, as well as protect it from what? Hacking. Because imagine if you put a camera in your house and somebody hacks into the camera. As you are watching, another person is watching, right? Which is very dangerous. So camera is just like an example. What of other things? Now we are talking about Ukraine war and everything. Sorry, what's it called? Israel is bombing Israel. What if people hack into a system and they can actually detonate a bomb? Like they can send off, what's it called? Jets. So in as much as the camera might seem trivial, there is a bigger part of it which is very dangerous. Imagine if I can stay in Nigeria and activate a warhead in America over the internet. Okay, who tells you that people don't want to do it? Of course, this is what people want to do naturally. But the only thing that can protect you people is your own firmware. So you need to be airtight so that people cannot hack into it. So when you have an object that is going to be working with the communication protocols, the other one, shall internet is not the only protocol. Internet protocol is called IP. The internet, we are going to come to all those things, right? There are other protocols, MQTT, ZigBee, LoRaWAN, and blah 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 blah. Okay, so that's by the way. Then you probably have something like system library. System library is now like okay, call it a library. Like if you go to a school and you want to gain knowledge, you go to the library and gain knowledge. So in that sense also, programmers equally have what we call libraries. So libraries is the place where knowledge is of any kind of code is kind of saved, okay, or archived or reposited. So if you know the library and what the library does, you can actually call the function of that library. Okay. So it's actually a standardized way of passing information. Okay. They have different libraries are you have Python libraries and all those kind of. So the question is that would you consider that library an OS? No. Would you consider library as a typical application? The answer is equally no. So there is a school of thought that actually say, okay, this library should be on its own. So these are system softwares. You can see in this case now, 1, 2, 3, 4, 5 are considered as system software. So please don't say that I am contradicting myself. I am getting you to understand different people's school of thoughts so that if you go to Germany tomorrow, you listen. It's not going to be different from what I've already said. Don't say, I deceived you. No, I want you to know the actual thing and the truth. So when you come to operating systems, right, the ones in red are the popular ones. Okay, you have Microsoft Windows. Everybody knows that one. That is actually what we are going to be using for DAIPODS. Sorry, if you are using Mac, it's very impossible to just be doing Windows and Mac. Maybe next year, God willing, we might have enough money for KodeCamp so that we can actually do for all operating systems. I'm going to be focusing on Windows and some of the Office tools for this particular application. Okay. Then Mac OS, of course, is for MacBooks. These are laptops that's produced by Apple. Okay. Now, number three, I didn't put it in red, but it's very important. It's called Linux distribution. Now, I have to say something here. Please listen carefully. Linux is Mac OS and Windows that I've already mentioned belong to a company. Windows belongs to a company called Microsoft, right? Mac OS belongs to a company called Apple Corporation. Linux is an OS that is made open. So this is if you're writing open source for the first time, let me explain what it means. Open source means like in the first two, Microsoft will employ engineers to be building their drivers, for uploading their, like you can see that they move from Windows XP, they move to Windows Vista, Windows 7, and which was that one that flopped? Windows 8. Windows 8, they move from Windows 8 to Windows 10, now it's Windows 11. What it means is that Microsoft is paying engineers, right, to build it. You don't have access to, but you are just using the Windows. Okay. So they are the owner of that. Mac OS, the same thing. Now, when you come to Linux, some people call it Linux. Anyone that is comfortable is not how you pronounce it that is important, it is the name. So let me just move with the trend. Linux, that's what I've been hearing. So let me just join. Not like I know what is correct or not, but that's fine. So Linux distribution, right? It is an open source, meaning that it is open for people to build. The person that started it is okay. You know what? I think I can allow people come together and build an OS. That is why it's a big difference from Windows and Mac OS. Because of that now, because you have opened it up, people will build different versions of it because there is no like Microsoft is looking, this is Windows 8, Windows 7. Because of that, you're going to be sharing something like distros. Okay? Distros. And when you hear distros, okay, please hold on. I need to share my screen again. Okay, let me continue. So when you hear distros, these are the terms, okay? Let nobody confuse you about it. It's simply referring to Linux specifically. Okay, distros means distribution. So distribution means, okay, we are using this hardware. At some point, we come together and say, okay, let us design one that is specific for a particular thing. Or I noticed that this one that these people designed, we might have to make an improvement. So I might just call a group of people, maybe 100 of them, and we design that particular one, we solve a particular problem, and we give it a name. When we give it a name you can give it to something like Ubuntu. Ubuntu was done by some people, I think Africa. So Ubuntu is actually an OS, right? A lot of people know it as an OS, but it's actually a Linux OS, not really Ubuntu. I want to begin to clear some of these things. There's what they call Fedora as well. There's Debian. So these are different distros. So when you hear Linux distros, so Debian actually is a software. Sorry, is an OS. Fedora is an OS. Ubuntu is an OS, depending on how you understand it. So please don't confuse yourself about it again. There are other ones like Unix as well. Unix like operating systems. You know, some of these cars are using it, even some printers, you know, you can see HP in their printer, they might not be using Windows. So you have to develop a specific OS for that scanner, for that printer, you know, for that photocopying machine and all that. You see buttons that they press there, you know, they press button and the thing obey them. So it means that those machines you are seeing equally has an OS, even though they don't have, okay, they have a screen, and most of their screens might be just what's it called? LCD, not like an advanced screen, you know. So now that we have mentioned it. Oh, I need to share my screen again. Sorry. Hold on. Let me mute. All right. So okay. So these are some of the OSs you are going to be meeting. You know, sometimes you have companies that will choose a specific one just because they want that premium. They don't want people to be they want to develop their own, and they go on for it. Okay. So some of these things So let's look at number 5. Again, another one in red. I think we are familiar with those ones. So operating systems, Android. Some people will Android. Please, Android is an OS built by Google to what? It is the system software of smartphones. So Samsung will build the hardware and they will adopt Android as the software. That's the OS and operating system. So I think the market now is dominated by Android because they are collaborating with a lot of companies like Oppo, Infinix, Techno, Samsung, Panasonic, LG. Is LG producing phone? I don't know, but they have a lot of partners, that they are working with. So OS is just meant for iOS. Okay, iOS is for Apple phones. So that is operating system for Apple phones. So the other operating system again, that are in black, real-time operating system. The real-time operating system, all these manufacturing plants, automated machines that the hand moves, you see manufacturing vehicles, something will leave the vehicle, turn it to the other side, another one will weld it and everything. This is not our usual OS that control these things. So you can have something like a real-time operating system. They are mostly used for things like embedded system, IoT, and all that. You have server operating system as well. This one helps you to operate a server. I'm going to talk about server. I've mentioned cloud a bit. There's going to be a time for us to talk about server. Some of those things they usually use what Linux server distros like CentOS and Debian server. Okay, you equally have embedded operating system. So now you know that operating system you know, uh, can be vast. Okay, you can see RTOS, that's real-time operating system, is a Windows embedded mainframe. So this is not actually exhaustive, but the aim is for you to have an idea and understand what it is so that it will be clear. So I'm going to bring up some part of this particular hold on. So how our software is built, we talked about this thing. I just want to summarize it and then move to what we have today. You have your high level language, the C++, the PHP, the Python, the Java, the Visual Basic. They will pass through different levels before they get to the machine language. Remember, the machine language is the 1 and 0 that works with your hardware. Okay, the high level language is basically, the one that you type on your terminal. We are going to talk about terminal very soon. Okay, so it is actually interpreted and compiled by the low level language. There's a language called assembly language. We don't learn it these days. It's for old school computer science people. Okay, you don't have to learn it. Remember, I talked about levels of abstraction in the last class. It's not everything that you have to bother yourself about. That doesn't mean that that level, okay, is totally eliminated. As you talk, any program you are writing and any command you are running still runs through the whole process, but there's separation of concerns now. Okay, this is simply showing what I've shown before. This is again the same thing. I talked about popular programming languages, talked about the coding, the programming software. I remember saying that coding these days, the job has been taken over by AI. AI can write codes. To some extent, AI can develop programs as well. But when it comes to software development, okay, programming, fine, but software development. So if you ask me, I would have said go straight to software development if you're entering tech, but it's not possible. So again, sorry, you have to go from coding to programming, then to software development. So the summary of it is in the next slide. Coding is specific act of writing code. AI does the same perfectly well, in all languages these days. Programming includes what coding, but extends towards broader process of creating a software. Somehow, to some extent, what's it called? AI probably does this now. Okay, but it equally needs a human because AI cannot wake up one day and start developing software. So you can see the last version of it, software development encompasses the entire life cycle of software development. You have to do conceptualize. AI cannot do everything. AI is not going to be the one that will come and say, okay, we need food delivery app in this local community and everything. So um, it cannot do everything, right? So that's the summary. Okay, let me now go to what we have today, right? So we are going to I just want to do a seamless transition. So when you see this particular slide, you're not going to be asking, why are we here? So this is the first slide in week two. Week two, we are going to be talking about operation and application and operation. So let us start with the operating system, right? So the one that concerns us, we are not. I know I've been mentioning Mercedes Benz recently, but of course we are not going to be. We are all here to learn specific things, and I'm not sure anybody is going to be using a car to learn code camp. So let us focus on the one that concerns us, and then you can probably start imagining the rest. Okay, so in operating system, of course, you can divide them into system and mobile. That's a simple way of categorizing them. Either you're using a laptop or a desktop or something, or you're using a mobile phone. So for those of us using laptop, the common ones you're going to see personal computer. Please see, I'm specific. Somebody should not say, "Oh, computers are made up of Windows and Mac." Personal computers, okay, because there is still when you are going to, for those that are going to do DevOps, you are going to be using more of Linux, right? We are going to come to that. We are going to talk about shell. So for personal computers, the most common is the Microsoft Windows. I'm using Windows 11, you might be using Windows 10, so far using Windows 8 and everything. No matter the window you're using, it's still different some company has it. If you're using a Mac, you're likely to be using Mac OS, Mac operating system, right? Then for mobile device, okay, you are likely to be doing Android if you have a smart Android phone, probably from Samsung or Techno or Infinix and the rest of them. iOS is exclusively for what? Apple phones. So these are the two that we have. Now you see that for computers, they've adopted Windows, right? So you can see a company like Samsung might have a system. They are going to be using Windows and they are going to be using Android. They're not going to say, oh, because Windows is applying all this OS for our laptops, let us use Windows for mobile phone. This is actually what killed a lot of companies as well. Some people don't know how to. In this tech thing, people have done a lot of miscalculations in the past. Example is BB, that's BlackBerry. So BlackBerry came, they were premium, they were the ones that introduced full keyboard in the phone world. So they introduced that technology, like a phone can now have the full keyboard. And then it is with BlackBerry you can check your email, for the first time, you can send email. So BlackBerry was built for business people at some point. The interface was perfect and all that. So what happened was that when uh, Apple, right? Apple is always the lead in this whole thing. They started using touch screen. When they sold that idea to BlackBerry, they laughed. Seriously, this is a real story. They laughed. These people don't know what they are doing because they felt like as having broken through that, people are now getting used to typing with their phone and sending email and everything. BlackBerry was having more than 90% of the total share of smartphones then. Okay. So something was wrong. You needed a PIN. That was actually one of the things. You needed a PIN for you to be able to send somebody message. So you need exchange PIN. So they made it exclusive and everything. Then WhatsApp saw that loophole, messaging, SMTP. We are going to talk about all this. Messages to be simpler and all those. Okay. They opened up WhatsApp. WhatsApp started getting momentum. Meanwhile, as WhatsApp was getting momentum, soft screen was equally becoming a thing, right? when BlackBerry noticed that the touchscreen has, people are now started using that's when they launched their bold something. I can't remember the first bold that has that thing, but by that time it was already late. People were already used to touchscreen Samsung, Techno, all those early this thing. I remember LG even had a smartphone at that point. So people have already adopted the technology. So what they did, I just want to talk to you about OS. So what they did was to try and make it look um sneaky. At the end of the day, the people that were sharing the market at that point was Nokia. Because Nokia had not really done a lot of smartphone, but when it comes to normal phone or making calls, eh, Nokia was even having like maybe more than 80% of the market share at that point. Again, they didn't see some of these things coming. They didn't just rival because their OS was different. I'm telling the story of OS now. At some point, what happened was that the Apple had what they call the Apple Store, yeah, Apple Store, where people can actually, build and upload their app. People that are using Apple devices can download it, and then you pay. That time you pay for every single thing. Okay, so having said all these things, I want to tell people how this Google and Android came into the picture. They saw the mistake Apple was making. They saw the mistake BlackBerry was making. They saw the mistake. What's the other one? Nokia was making. So they said, okay, let's do an open source. So Android was an open source, meaning you can now. I want to understand some of these terms. They created an open source, which means an ordinary person like me can build an app that people are going to be using, upload it for free, and people are going to download it. So I will have a Google Cloud account that I'll use and build my own. So Google is not paying me. I'm the one that's really building. So I can put it up there. And most of them at that time was free. So what Google did was, okay, before you get this phone, you must have a Gmail. And that was how the Yahoo started dying. So you have to get a Gmail. That time, you just open your phone, see icon. It was very nice, icon everywhere. Just touch, download. You touch in your phone. You are playing games and everything. It was mainly games at that point. You understand? Before, of course, they didn't start with bank app and all those kind of things that we are seeing now. It's just mainly games. Okay. When it started working, Nokia now wanted to. Okay, there's one Nokia Lumia something. I can't remember the name specifically. What they did was they now rushed to Windows and say, since people are already using the OS, and that's the reason why I'm just telling this story. People are already using this OS and they are comfortable. Let's do now build a Windows phone. Imagine how beautiful it's going to be. That's people that are already using Windows can now jump on Windows phone. The mistake that they made is that people know Windows and they're using it in their laptop and in their desktop, not on their phones. If Windows came out before this whole Android thing, it would have been a different ball game. But you are coming in at a point where people are already getting used to this, touching icon and then it will open. Windows does not do icon, right? So you have to probably sometimes go to my document and all. You know how Windows operate now. So it is not something that is really built for phone, but they insisted, right? Nokia specifically insisted. If Nokia had gone for Android at that point, Nokia would be one of the highest selling now. But Nokia made a terrible mistake. They went for Windows. It is fine, okay? So you open you buy a phone. People that actually wanted to patronize them that we are excited about the whole idea of Windows phone, you buy it. It's looking like a laptop. You open it, you have like a start button. Everything is just confusing. You know, that's what flopped. So Nokia, because they've signed a deal, they are not going to be using Android at that point. Nokia just died a natural death. They could not match up because you can't be building the old Nokia that sold that time. You have to, build stuff that will match up with the current, not really the current, the trend then. Okay, so when that happened, you know, they even said, let us throw it to PC. So they use the same. If you notice, Windows 8 actually adopted that model of smartphone technology. So they threw it to Windows. That was why Windows 8 was a very, very big failure. Windows 8 is actually a very good this thing, but guess what? At the point they were building, they forgot that phone was what? Touch screen. Laptops then were not touch screen. So you're building Windows 8. If people come, they don't even see because people that use Windows 7 was already Windows 7 was working. I don't know why they just decided to throw in Windows 8. Windows 8, you have your start button and all those kind of things. I don't know whether these Gen Z people understand what I'm saying, but if you ask your parents or something, Windows 7 was just nice. They threw in Windows 8, all of a sudden you open. Color everywhere. The thing is supposed to be flying from left to right, right to left. But that actually, if you go back to Windows, you see that Windows was supposed to be built for touch screen, but it came before its time. That's what killed Windows 8. Windows 8 did not come at that appropriate time. Because if Windows 8 came out now that a lot of laptops are becoming touch screen now, yeah, it will be easy. So Windows 8 was a disaster. And that's why, if you notice, it didn't last. They had to rush and do Windows 10. Windows 10 was Windows 8 died on the altar of Windows 10 so that Windows 10 can live. So Windows 10 came in, you can see it lasted. Some people are even still using Windows 10 up to today. They brought back the start button, that will open up your menu and all those things. Now, why am I telling all this story? These are all about OS. You can see that the it is very important choosing the right OS for whatever you are doing. You don't want to be frustrated. Okay. So some of these things that I have mentioned, are real thing that helps the class to be seamless. Let's now go into the whole operation. Okay. To put on any system, whether it is a phone, you notice that it is not like a television that you can just press one button and everything will come up at once. Even televisions now are becoming what? Televisions are becoming computers as well because they now have some level of what? Operating system as well. Samsung, when you buy this when you hear smart television now, okay, even though it's not touch screen, but most of the LEDs now are coming with their own pre-installed software, which is app, meaning that there will be an OS on that LG television upon which these apps will be installed. So, what am I trying to say here? Sorry, I'm not trying to talk about LG. I'm talking about booting. So, holding television, just press one button, everything comes up. Now, if you are dealing with a system, it does not work like that, right? That's why if you put a smart screen television, it takes time before it comes. What actually happens is booting. I'm going to talk about what booting is today. So, um, let's go to the next one. So the button now, if you see any button like this, it's simple. This is IO. When you hear IO, okay, it is this one. Sometimes people can equally interpret it as 1 and 0. Okay. Yeah. So you can see I kind of screen different kinds of, whether it is a desktop, laptop. Check your device. You must see something like that. Phones these days, they don't have enough space to draw this big thing, but you have your button that is going to be used for on and off, right? So please, let's talk about the important things here. What is booting? Level 1, level 2, level 3, level 4. These are things that happen. That's why you are going to be what? Going through these processes. Number one, okay, look at the right hand side. Whenever you press that button, the first thing that happens is that your BIOS is loaded. BIOS is what? Basic input and output system. Okay, that's the first thing, because if it is not loaded, okay, you notice that even sometimes before your system starts working, shake your mouse, you see that your mouse is already moving around the system. It's because that BIOS has already connected to it. There are basic and output and inputs. Like that, your screen is actually an output device. So it connects to the screen, everything starts coming on gradually. Okay. Then the POS is completed. I'm going to show you like a diagram, okay, that shows everything here. Then the OS, the operating system is loaded. Okay. When it's loaded, what do you see? You see Windows appear. Oh, one sound will come out. That's the third level of the process. Then your desktop will start loading and everything. After that thing, the next thing that will happen is your system configuration. There are a lot of configuration in your system. I've mentioned drivers and stuff like that. It begins to connect with some of the drivers. Okay. The buses, address bus, data bus, and the what's the other bus again? Address bus, data bus, communication bus, yeah. Then system utilities are equally loaded. I talked about utilities, right? Your antivirus, your system configure, performance system performance checks, and then it will now ask you to authenticate the user. Okay, either you put your password and something like that. So this is what they call bootstrapping. Some people think that bootstrapping is there's this framework called Bootstrap that people use for front end CSS stuff. So we are not talking about that. Bootstrapping means how the boot actually is a short form of bootstrapping. For this, if you're hearing it for the first time, yes. So what you are doing is you are bootstrapping the system. The computer must put itself on, then automatically or manually start booting. This booting process is what I have just talked about here. Now, the actual steps that happen is it is loading and is initializing the kernel. You see, this word kernel is actually the guy that connects the operating system and the hardware. That's the handshake. Anywhere you go to in the world, say what actually connects the software, that is the operating system and the hardware. Brothers and sisters, is the kernel. That's the guy. Okay. So creation of spontaneous system processes. Okay. That's the system configuration we talked about. Execution of system startup scripts. Then multi-user operation. That's authentication. So I will prefer the one on the right, okay, than the one on the left. Now, application, okay, you see what happens here. The kernel is what connects the application, okay, and the hardware. Okay, so that kernel is
Sorry, sir, we can't hear you again.
thank you for that prompt. I hope you can hear me now. Can you
Yes, we
hear
can
me
hear you,
now?
sir. We can hear you, sir.
Okay, thank you. Thank you for that prompt. I didn't know. Please, when you don't hear me, let me know. You understand? So I can quickly. All right, thank you. So I was saying that the kernel, let me just repeat this slide a bit. So the kernel is the most important part of the operating system. It is the primary interface between the hardware and the processes of a computer. So anywhere they ask you, what is that thing? This way, hardware, software, hardware, software. what is the handshake between hardware and software? Ladies and gentlemen, the name is kernel, right? So on the right hand side, you see there's an animation there. Your kernel can, there's no way the user can interact with the hardware. So the kernel can grow to contain other things. It's just a matter of rearrangement, right? System files and stuff like that. So it depends. But without the kernel, your system will not be able to come up. Okay. So that's part of the booting. We are still talking about booting system. So you can see in a nutshell, this is what it looks like. So whoever that is using the system, there's something in the operating system that is actually connecting to the real hardware, right? That is the kernel. You can see how important it is that your brain of the system, which is the CPU, the memory, the secondary device, the secondary storage, that is the disk, and other devices like IOs. This guy is the one that is connected to most of them. So you can see the booting system also. I just got this just to kind of from byte go to just show process one. When you buy the BIOS, basic input and operate, it detects devices. That's the configuration. You choose a booting device. If it's something that you want to maybe install, it boots it, and then the next thing is the execute system commands, and then from there it connects to files, and then you can run your script and everything. So this is basically, I'm not showing you this thing for you to learn. I just want to show you that first of all, you see the basic thing. Okay, you see that there is power port in there. It's going to run through your BIOS. Okay, then detecting devices, like when we talk about device configuration in the other one. Okay, so then there are alternative processes. I can move from 2 to 4, sorry, from two to five, right? Now 3 and 4 in this particular one is just showing that you can actually, boot, when you put your system on and it doesn't have an OS, you can boot your OS from either a disk or a flash drive or an external hard drive. So that's what it's showing here. So 5 is where it's executing the command. Of course, the user is already is already interfaced. Well, that's why I say first process in user space. Okay, so basically you can see 6 is just writing codes. 7 is running the code and everything. So this is a different kind of. You can on your system just to watch movie. You must not write code, but you just have to understand this. For Linux, it's actually they use it more for system admin. You are going to come to all these things. Now, when this thing is happening, the first thing will happen. The first thing that will happen is that your OS will come up, okay, and then this is what we call um your desktop. My desktop is very busy, right? You can see the guy there is ready to rock, he's ready to roll, typing music and everything. What is showing here is that the OS has come up and is now presenting all the application software that have been installed in it. I can click on any one and open it, right? So the first operation, okay, for using we are going to talk about GUI and CLI, is the mouse. Sometimes you use your system pad. If you're using a laptop, there's what they call touchpad. People call it mouse, but it's not. It's a touchpad. Is doing the work of a mouse. So for me, I will equally advise, because as we are going in this journey, please, if you are using touchpad, go and buy a mouse. Touchpad is not natural for the hand. There's what they call repetitive strain injury. When you are using your touchpad, okay, the if you are right hand, if you are right-handed, yes, if you are right-handed, you will notice that there is a joint. If you are looking at your palm, at the back, sorry, the back of your hand, okay, the downside that is joining the bone to your hand. There's a difference between hand and arm. Arm is from your finger down to your shoulder. But when you talk about hand, hand is your fingers and this thing that connects everything, stopping at your wrists. Okay. The left hand side of your wrists, if you are always shaking it, clicking and when you grow old, that place will be shaking because you have destroyed the muscle there. You have done it for more than 20 years. Okay, that's what they call repetitive strain injury. It is gradual, it builds up, and very dangerous because it does not kind of pain you when it's building up. Okay, so it is better you buy a mouse. If you check mouse, you see that mouse takes a natural shape of your finger, of your hand. Okay, you can now be moving it. So this is my advice. I just have to use this opportunity to talk about it. So if you are using your touchpad, please try and get a mouse and connect it to your system. Okay. Okay. So talking about mouse, yeah, there are, of course, you see the knows. Everybody knows this one now. So you have your right click, you have your left click, you have your wheel. Wheel is the one that you use to scroll up and scroll down and all that. Of course, cable, or you use what they call wireless dongle that will connect your mouse through a technology called Bluetooth. So for the left click is actually the normal thing. Okay, just have to select something. Okay, sometimes this left click and right click can confuse because left click is just natural. But people, when you say left, the way people think about left, they're actually thinking about right. So left click is the normal one. Of course, how you hold your mouse, you see the left click there. That's what you use to select something. Then the right click is when you right click on something, what you're trying to do is if there are other options, right, for that particular in programming, you have something like class and methods. I'm not going to like dwell on that now, but just take it this way. If there are other things, that particular thing you are clicking on, you can be clicking on a link, you can be clicking on a button, you can be clicking on a video, you can be checking a box and everything. So if there are more options, you are using right click to see all the options of the commands that you can actually execute. The next one is drag and drop. Okay, double clicking. There's double clicking. Double clicking is used to opening files. Everybody knows this one. Most of the time when you are doing online, you're just going to click. Then click and hold is to kind of select something that you are going to transfer to another location. So you can drag it and then you can release. Okay. I'm not going to dwell so much on this, but we are now starting the operation. First of all, what you have on the screen is what you are likely to have on your Windows. Like I said, this class we are going to be using Windows. Sorry if you are using Mac. Okay. What is the first system? Watch your window very well. It's divided into three, basically. Sometimes it is long, sometimes it is short, but I'm going to bring three of them out. The first thing you see there is a start menu. It's going to have one, the Windows button, two, the search button. I don't know what else might be there. But you see Windows button and search button, they are very important. Windows button, when you click on the Windows button, it gives you many other options. Like you can go to your settings, your configuration, your control panel, and a lot of them. But the search, right, is even more helpful in the sense that you can search anything, whether it's a program, whether it's a file, whether it's a program, whether it's a directory, okay, whether it's an application, you can search it, okay. So the other one is just showing you, if you click on it, it's actually tabs, but the number of tabs that are open. I'm going to talk about tabs. The next thing that is going to be in the middle is called task bar. So menu bar, task bar, and then system tray. Okay, let me go back to task bar. So these are the three: menu bar, task bar, and system tray. So task bar, whenever you open any app, is going to appear on your taskbar, right? So that's the way you can easily navigate, from one app to another app. So it is going to reduce the amount of minimizing and maximizing you are going to be doing. So you can go straight to, like, you can see Google icon there, you can see Edge, you can see PowerPoint, you can see all these things are open. When I click on them, if there are more files of Microsoft, it give me all the files that are open, then I can click on any of them. When I say click, just remember it's just left click. Now, system tray is a location that gives you some important configuration of the system you are using. For instance, weather. If you are connected to the internet, okay, there is this thing Microsoft has done. You can see your weather. There are other things like volume, the battery, whether your video webcam is on, your Wi-Fi, and everything. So this is because we are going to come to these things later. the dates, okay, and some of other utilities that are stored in this system tray, okay, and you can actually remove some of them, but that's not why we're here today. So let's talk about the shutdown. This thing I've talked about booting. Shutting down is taking the opposite side of, oh, sorry, the opposite sequence. Yeah, the opposite sequence of booting. So the way you boot your computer, that's how you're going to shut it down, right? So that's why you are not advised to, had is it shut it hard? There's a name that is used to just press your this thing and shut it down. It's only when probably your system is hanging that you're advised to do that. Even if it's giving you a sign that is getting slow, okay, what you do is shut it down and allow it to, or you can do restart. Most of the time, if you're having issue with your system, shutting down and restarting can solve it. We are going to talk about it very okay. I think I've talked about cache. It might be your cache that is causing the problem, right? So let's define each of these. So when you go to your Windows button, remember I mentioned Windows button in the start menu, you click on it, you're going to see the IO button, that's the off and on button. You click on it, you're going to see different options. Now, let me clear all these options. The number one is sleep. If you sleep a system, please, ladies and gentlemen, that system is still on. What you are doing is you are putting it in a low power state. Okay, but everything is still on. If you leave a very long time, the battery will die and the thing will shut down. So don't think that sleep will keep it. No, sleep is simply putting it in a low power state. That's the truth. Okay, so it can last. Okay, it can last. So there are some people, we're going to talk about configuration. Okay, when I close my laptop lid, what happens? Do I want it to sleep? Do I want it to hibernate? There's a way you can set all those things. Do I want to shut it down? Okay, so it depends. So the next one, let's just look at each of them. When you hear hibernate, what hibernate does is you are actually shutting the system down. Okay, but before you shut the system down, it will take like a picture. Let me call it a picture if you understand it better that way, of everything that is going on at that point. So with that picture, when you put it on again, you will start exactly from where you stopped. Okay, meaning that is that picture now is what we call session. So when you are working with your system, you are running a session. Okay, sometimes that session will be Microsoft Word is on here, the Google browser is on here, and everything. It takes, okay, before you shut down, tell you hibernate. When you hibernate, okay, hold on, sir, let me know. Like, just assume that if you are playing chess, sir, hold on, let me know where we are. It takes record of everything, then shut the system down. In this case, the system is actually shut down, so nothing, you're not losing power. The difference now is that when you put it on again, it goes back exactly to the place where you started. Okay, so shutdown closes every app. When you actually shut down a system, you close the app and turn the system up. So when you turn it on again, you're starting from beginning. Just like you're loading the desktop. Okay, no app will open until you probably say, okay, I want to open this app. So it is not saving your session. Restart, okay, is you when you choose restart, you're actually shutting the system down. But after the system is completely, gone down, it will actually reboot again. So that's what restart means when you choose that option. Today, we are going to look at file systems. Okay, we're going to be looking at file systems. And we should conclude this day. We are going to introduce a little bit about. We're going to write some codes like CMD, but file system is very, 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 very important as well. So Okay, so before you even start talking about using a system, okay, how are things arranged in that system? What configuration do they use? So file system is actually a standard, right? Like a, okay, let me not call it a protocol because there's a specific name for it. It's rules, that guides how your operating system. Now we are talking about operating system, organizes and manages file. Because yes, the system is on. Where do we go from here? You need to understand files. And the reason why we are doing this thing is that so that you be different from somebody that just know how to put a system and start using it. Okay, so you be in this class, it might not be like, but it's really, really important. This is, some things that a lot of people don't know. Okay, now let's talk about file systems. Why do we need a file system? You may ask. Okay, the answer to this question is on this slide. Okay, number one, the organization. See, without file system, people will not be able to use this your this your phone. No, you understand? When you take picture, it will enter anywhere. When you record voice, if you do a video, it will enter anywhere. The reason why you're able to use your phone is because of this man that is on this slide. It makes it easy. When you dial your number, you go to contact and everything. You might not understand how important this is until go to a system where there is no, go to a file where there is no system. I know some of you do the same thing. A lot of us on this slide are used to everything save into documents, save into documents, save into documents. But the day you are going to look for information, but you go cry, as in the cry, the tears no be here. You go look tired. You understand? So because of that, we need to understand what we call, the organization of your file. Two, apart from organization, how do you identify? Guys, even those that organize their file, even if you are very perfect in organizing your file, one day you're going to look for something. And the only thing that will save you that day is the identity of that file. That's why we have a search button. Okay, so you can see it's not just organizing files, okay? Search as well using the identity of the file. So number one is what the organization, number two is now the identity. Okay, let's continue. Number three, access control. So if you organize your file very well, what if you don't want people or a specific people, or this is one very important part of file system for those that are going to be writing codes. Eh, passwords. How are you going to be arranging it? How do you want to do the architecture of everything? How do you want to give access? Please pay attention to these things because I'm not just talking about file system. Remember when I said that computer can write codes, but what computer cannot do is to be creative and be able to, okay, we are going to build an app that can do ticketing for an event. So how is it? AI will not come up when they say, I want to build an app that can ticket events. And then you want to know, okay, what kind of access will Google give you so that people will not hack and produce their own ticket version and come into my show without paying. You're already thinking. Organization. So please, this is not what DAIPODS is just teaching this. No, it's going to, when you start, this is what the system software developer does. So it's not just writing codes. So I want us to start developing that mentality. They are not just in this thing to just come and learn how to write codes. Okay. Number four, data retrieval management. So whatever data you are storing anywhere is just for one purpose. That one day you are going to ask for it. If you don't actually do an organization of how you are going to ask for it, you are going to have problems seeking for that distance to be retrieved. Okay, so that is one of the reasons why we need file system. Okay, having said all these things, then I'll talk about the device itself. Man, the device, remember that space, so if you have a lot of space there, how do you allocate, memory to every component in that file? How do you keep track of it? How do you free up storages when you need to free up storages and all that? Okay. Please, this is the reason why I talk about this thing. Let me go back to this because I like taking this thing gradually. File systems are, okay, a standard used by an operating system. I want you to connect this thing, okay? Standard used by an operating system to organize and manage files on a storage device. Why are they needed? File storage and organization, file naming and identification, access control and permission, data retrieval, and management, space allocation and tracking. Okay. Again, let me go back again. Standards that operating system uses to manage and organize information. Okay, now let's go in. When we come to disk, there are different kinds of file system you are going to have on disks, right? This is disk based. Okay, this is disk based. Number one is FAT. I know some of you would have been seeing some of these things, but you might be asking yourself, what are these jargons? Please, is my screen still visible? This slide is very important. Someone should confirm, please. Okay. All right. Thank you, Luchu. So now, the first one is the full meaning of FAT is, see, I'm not going to just list this thing so that I cram the name and go, right? There's what they call file allocation table, okay? Now, this is the oldest. Why is it called file allocation table? Now, there's a way, you see this thing I showed you? Okay, let me go back a bit so that you can connect. Like I say, I like telling stories so that it will not be difficult. You see this thing I just listed here? The first people that started organizing files actually put these things in a table. So when you come to the table, you see something like, how is this file organized? What is the name? What is the kind of access control? What is the retrieval method? And where is it located? So just picture this thing you are seeing here as a table, right? Not exactly this, but that's how best I can make you understand it. So they call it file allocation table. So in that file allocation table, okay, it's actually used by specifically Windows operating systems, right? So it is older Windows versions. So they have version. So when you see FAT12, FAT16, FAT32, it means different versions, right? It means it stores information 12 bits, 16 bits, and 32 bits. Okay, so we have that information stored. That is the system that helps file organization in old Windows systems. Okay, so it's called file allocation table. So that allocation table is what can help you manage the identity, the retrieval, all those things we mentioned before this thing. So they had what? FAT12, FAT16, and FAT what? 32. That explains it. Let's come down a bit. You see NTFS. This is once when you right click on any folder in your this thing and click, okay, let me just show you an example. Just let me show you an example. So if you can see my screen now, okay, let me right click on, if I right click on any of these, okay, I'm not seeing my mouse. Now what happened? Okay, I can see my mouse now. So if I right click on any of these, my document or something, if I right click on them, and click on property, you are going to see some information. So some of this information you are seeing here, okay, is very important. Some people don't know why they are there. You can see, start taking note of. I'm sure some of you have never touched some of this area. Okay, can you people see my screen? Someone should just answer yes. What I'm doing. Okay, yeah. So you can see this is normal. If I right click this normal folder, this is what you do every day. You click on properties. Now you're going to see this. Just imagine. This is general. Everything you're seeing here is general. No, nobody has ever touched this tabs before. So general will tell you, see that kind of thing I'm talking about. What is the type of the file? What is the location of the file? What is the size of the file? What is the size of the file on what disk? How many folders are the file contain? When was the file created? What kind of attribute? Is it read-only? Is it hidden? You can go to advanced. So I am now showing you some things that other people don't know, right? You can see another tab. Now, if I click on this tab, things have changed. You see? Sharing. You can go to advanced sharing. You can do some settings there as well. So those files that you don't want people to kind of get access to, you can see security here. Okay, you can do some configuration. We are not doing configuration here, I'm just showing you first. So understand file system is very important. So the reason why we are doing that is to bring everybody like elementary, just to teach you every single thing. You understand? So you can go to previous version, customize, you can customize it and everything. So if you have never used this before, I'm just showing you, like we're not going to use them now. I'm just trying to define file systems. Now, if it is a drive, let me go to a drive. Let me see drive C now, right? If it's a drive, let me right click on drive C, click on property. It's not going to be the same thing. See what comes out now. It's not the same thing with the other one that came out. This is a drive. If it's a flash drive, if it's a pen drive, if it is a ROM and everything, what's it called? A ROM, that's read-only memory, like your disk. This is the kind of thing that you're going to see. You're not going to see the other one like an ordinary folder. This is a drive. So remember, when we talked about drive, it will have its own file system. I don't know how visible this is, but you can see the file system here is NTFS. That's the only thing I wanted to show you. I didn't want you to start manipulating this folder yet. Okay, it's NTFS. Okay, I don't know whether you can just say yes if you can see it in the chat. Let me just confirm. I don't know how tiny this is on your own screen. I need a yes on the chat. Can you see my screen? Okay, yeah, people are saying yes. Okay, so you can see NTFS. So I'm going to close. Please, I'm not trying to get you to manipulate anything. We are going to come to it. So I just want to see NTFS. So what is NTFS? NTFS is New Technology File System. It is moving away. You will not see anything like FAT64. FAT stopped at 32. And they discontinued that particular file. Remember, we're talking about Windows now. I'm going to talk about other operating systems. So they're now using what? NTFS. NTFS means New Technology File System. This is the additional, because there have been improvements, okay, used in Windows, supports large files. This FAT, if it goes beyond bit 32, forget it. That's old technology. This one supports large files, it supports encryption, and it supports what? Some level of permission, right? So that's why you can see in my system right now, it is using NTFS. That's why it's called used in the new Windows. Old Windows, you use FAT. Now, XFAT, okay, is what they call extended file allocation table. So the X is extended. FAT still remains FAT, extended file allocation table. Now, we are moving away from Windows. Just follow the story now. We are talking about flash drives, right? So for flash drives to support large files like Windows and everything, the flash drive is an external drive. It's not really a Windows-based drive, okay? We are going to have to format it, because now I'm going to be putting some terms, right? All these things we are seeing here is the way a particular drive is going to, or a disk, because look at the topic, disk based file system. So when you are formatting, you need to choose the correct file system when you are formatting. Okay, so most flash drives will be formatted as XFAT. Okay, now haven't talked about flash drive. Flash drive, we're talking about both external hard disk and all that. Okay, now let us go to Apple systems. You can see how I'm taking it. For Apple, Windows is using FAT and NTFS. Apple is using what we call hierarchical file system plus HFS, okay, used in older Mac OS. But in the, just like Windows have FAT, Mac OS was using HFS then. While Windows, you can say that they are now using new technology file system, NTFS. Apple is now using APFS, that's Apple File System, right? So just do that analogy, okay? The last one we're going to talk about, I talked about distros, right? You see, this thing is becoming simpler. Like when I say learning distros, people will, okay, yeah, he mentioned it. This is how this whole tech thing goes. You just learn the thing naturally. So you have um, EXT1 is extension one, extension two, extension three. So that's like the progress that they are making. When you are using Linux distribution, you format your drives as ext1, ext2, ext2, sorry, ext3, and ext4, right? So having said all these things, okay, what you need to understand is that you need to understand the file system that is proper. Ladies and gentlemen, this is the reason why I know some of you don't know when they carry their flash drive and you go and meet that your friend, you want to go and watch a movie. People are suffered after storing the movie in the flash drive. You now go to Apple and chook it. But where everything is appearing strange. People are not sorry. Probably if you have entered Dubai of 8,000 naira from one location to another to go and relax, you have bought popcorn and you now want to watch the movie. And your friend is having an Apple MacBook, okay? You plug your this thing, it's not even seeing the flash drive. I hope I don't need to tell you what has happened with this class now. I think you can, if it has happened to you, sorry, I'm learning it for the first time. That flash drive was formatted wrongly. Probably it was using NTFS. And you're not going to somebody that has a laptop and you go and check it, you want to watch your movie, Moto. You go explain, tire, no evidence, like you cannot watch anything. What if it is your final A project? You use your Apple, after doing this thing, you forgot to make sure that this thing, you don't go to your printer. Your printer is even using old Windows that is using FAT12 self. You're not printing anything, no. So people should understand this thing that is not really village people. Some people are so superstitious. Once they have problem, it is village people. So understanding this thing will have to kind of help you save, that's this thing. So now there are other file systems as well. Network file system, okay, it allows remote access of files over the network. Where you are talking about um, cloud computing and all that. There's several message block, another file system used in Windows network for file sharing, and the CIF, Common Internet File System, older version of SMB. SMB is server message block. So again, I am not doing this so that people will cram it. I just want you to know that first of all, there is what? Disk-based file system. This is the one you bother yourself with. Until those that are going for DevOps and cloud computing, get ready. People are going to meet this one later. And then there's what they call virtual file system as well, virtualization, process file system used in Linux for processing information. And then there is system file system, SysFS. So FS, please don't really cram all these things. There's actually specialized one where you are doing zettabytes. Zettabyte is, of course, I've told you about gigabyte, petabyte, and everything. This is one there's the what we call migration. For instance, you have been doing on-prem, and you want to migrate to data this thing. You want to start using public cloud. We now don't get like how many petabytes of information. Do you think that this one where they use transfer for flash, that's what you're if you sleep there now, it will last for 1 week. You know when you put flash, it is that green thing that used to read that they call it progress bar. Go and transfer something that is petabyte now with that same file system. I'm sorry for you. So you see now, if guys are beginning to understand that there are levels to this thing. If you want to migrate information, your company has gathered over maybe 10 petabytes. You know what is petabytes? And if you want to migrate, you see you are going to be using I think those that have changed system can bear with me that, oh boy, if you want to take your this thing, especially if your hard drive is about crash and they tell you to transfer your information to you go transfer it, no they even read. The thing is taking time. I'm sure some of us have experienced this thing. Go and check the file system you are using. So you can see zettabyte, like if you want to move, the thing will just move. Pia. You won't be wondering, like, no, it's because of the file system. Amazon cannot try to migrate you and they are using the normal file system to migrate. So I want people to know this. So I kind of came up with this, okay, mapping operating system and storage devices to the commonly used file systems. Probably I will share this with you. Of course, you don't have to cram it. Just I have explained it very well. If you look at this table, there's nothing really. Okay, is it Windows? Is it SSD? Is it HDD and all that? I've really, really explained it. So having talked about file system, this is what I showed you earlier. This one using XFAT. Okay, it means is what? Extended file system is a USB. You can see USB drive. So it's using extended file allocation table for it. So we are going to be rounding off for today. Once we do this, this now is hierarchical. This is equally, some people refer to this as file system, but I've actually told you what file systems are. Okay, so this is more like file organization. Okay, so your file is organized in a hierarchical way. Hierarchical means, of course, when you have hierarchy, you have people with superiority, kind of. Okay, so the highest this thing is drive, followed by directories, followed by folders, and followed by files, right? So let's talk about directories. Okay, directories is when you come to your secondary memory. Now I'm referring to secondary memory. You have different directories, right? You have A, you have B, you have C, you have D. So if you have something like drive A, drive B, drive C, most of the time what you are going to be seeing is drive C, which is the internal hard drive of a system. Okay, so some people might be asking, why are we even starting with C? You cannot see anything A or B, you must see C. Okay, when you now see C, you can continue upwards. Okay, I'm going to explain it very well. One, A has already been taken and B has already been taken. What took A and B? In the olden desktops on the olden systems, there is a magnetic tape which took A. Then there is a floppy disk which took B. Now, those technologies have been phased out. Because those technologies have been phased out, that does not mean that you are going to get lost. So the internal hard drive of a system was now allocated drive C. So you cannot bring back A and B. So most of the time, what you're going to be seeing is drive C and above. Okay, so drive C is the hard drive, that's the secondary memory of your system. If you buy a phone, okay, you have your internal, what people call internal memory. It is your kind of drive C in the phone as well. If you took anything, if you kind of add anything or integrate anything, if you kind of plug a flash drive, right, it is going to allocate the next letter to the flash drive. Or if you partition that your hard drive, that's your internal hard drive, partitioning means just dividing it into two. One is going to be, the main one is going to take C, the other one is going to take the next letter, which is D. But if you don't partition it, Okay, so if you partition it, when you plug a flash drive, that flash drive is going to take the letter A, B, C, D. That flash drive is going to take the letter E because you partitioned it, and the one part of your hard drive is C, the other part of your hard drive is D. Then the one that you are adding is going to take the letter D. Okay, if you plug an external hard drive into another port, it's going to take the letter F. So you now have drive C, D, E, F. Why am I missing these things up? But I hope you understand what I'm trying to say. So if you have only one partition, it means that the whole partition is C. So when you plug a hard drive, it's going to be D. When you plug another thing, it's going to give you another thing that is not like I'm not talking about mouse, so I'm not talking about printer. Any storage device you add is going to take the higher letter. So it go on. So some people have what we call extensions. For instance, you go to a printing place, you see that they plug something like an adapter, okay, that will now have many mouths, okay. So it can take, let me say, four different flash drives because they don't want to be. The idea is that they don't want to be turning their desktop always to go and plug mouse and then turn it again to remove. So they will plug that I'll call it an adapter or extension, then put it on their table. It will now have USB, ports, maybe 4. So if you plug a flash drive, okay, it will take the letter D. Another one will take letter E. If you plug the extra hard drive, it will take letter F, A, B, C, D, E, F, G, H, I, J, K, just like that. So I hope you don't understand what I'm trying to say. Now, it doesn't equally mean that those letters will be permanently assigned to that flash drive. Let me create this scenario. If you unplug the flash drive and unplug the external hard disk, if you plug the external hard disk first, it's going to take the letter D. If you plug the hard drive second, it's going to take the letter E. If you do it the other way around, so it's not something that is like, okay, this flash drive. So just be noticing it when you plug something, check the letter that is attached to that. Okay, so that's the drives. Okay, these are then under the drive, you're going to have directories. Okay, these days there's really no difference between directories and folders. Okay, they are now using interchange. I have to just mention that. Okay, so for Windows, directories means like there are some folders. Okay, that's the interpretation that come with the Windows. After installing your Windows 11, I'm not sure you're going to be installing or creating a folder called music, or a folder called download, or a folder called my documents, or a folder called my videos, or a folder called my pictures. If you notice very well, some of these folders are already pre-installed in your system. So they are referred to as directories. They are actually folders. So that's what I'm saying. Sometimes it's just semantics. So they are folders because you can put a lot of things inside them, right? But it is helpful for organizing your files. That's why it's divided that way. Because they know that you're going to have documents, you're going to have music, you're going to have videos, you're going to be downloading things from online. So Windows, okay, when they are creating their OS, actually create some of these things. When you install it, they come pre-installed. But folders, is the one that you can create yourself. You can name it. You can create folders inside folders, inside folders, inside folders, and then create files. Of course, you know what I am talking about. So now let us talk about file pathway. Pathway. So pathway is actually when this is my PC, for instance, okay. I'll give you an example. Inside my PC, you see, I have this is the highest level drives. So I have demonstrating on this slide, you can see I have drive C, drive E, and drive F. Okay, so these are the drive level. Then under the drive C, you're going to have what? C dot dot slash. This is the connotation of the pathway for drive C. So it is only the drive level that will have this semicolon. Others, you notice as I move forward now, you're not going to be seeing any semicolon. By the way, this is what they call backward slash. Follows forward slash is the other way. This is backward slash. So in file pathway for Windows, you are going to be using what? The backward slash. Now, under the drive C, I'm going to be having a lot of things inside. Okay, some directories inside. So the drive C, it will have like the program files, users, the Windows, performance log, and all that. Okay, so sometimes you have some people might ask, why am I having program files and then program file x86? Some people will be confused. Okay, to clear all that, program files are just 64 bits program files. When you have program files x86, it means that program you installed in your system is a 32-bit program. Though I am not discussing software package now, but I just want to clear it for in case people are asking for that. So under drive C, I want to go into user. You can see. Now, what I'm going to do is users, you can see the same spelling, don't miss it. I don't have semicolon, sorry, colon now. You can see it's only in the drive level, whether E or D or C, that are going to have that semicolon. So under users, what do we have? Now, these are the user profile I have created for this particular Windows operating system. So I have Mr. Lawrence. I'm going to go towards Mr. Lawrence. So Mr. Lawrence, again, backward slash. We're going to use this thing in command prompt next week because the way I'm looking at time, we're not going to be able to do command prompt again today. So under Mr. Lawrence, I have a lot of subfolders and I want to go to what? Desktop. Okay, I'll type backward slash desktop. So I'm going to stop here. I can see there's no other backward slash because I want to stop here. If I want to go deeper, I'm going to go into it. So Windows Explorer, we have, if you open any Windows Explorer, just open any folder, okay, you're going to have tabs. So let me introduce this opportunity to introduce tabs. So what you're seeing here is the home tab. Are you seeing it? So the home tab, why you are seeing the other part of the red distinct is that everything under home tab is referred to as a ribbon. These are the terms you're going to be seeing in this class for a very long time. Okay, so we are going to have share. You can see share. You can click on the tab share. The tab share will open up its own what? Ribbon. And then there is a tab view. Mark my terms, tabs and ribbons. Each tab will open up its own ribbon. Okay, so the ribbon contains commands that are related to that tab. So if you look up again, you see that home tab, you have what? Pin to quick access, copy, paste, cut, and everything. All those commands, all those icons, yeah, they're actually commands. So when you click on it to give a particular command, you have your share, and all that. You have your view and so on and so forth. So we're going to talk about this later. What I want to do today is to kind of tell us the difference between the GUI and the CLI so that next week we go straight to command line interface. So what is GUI? GUI, you can see I deliberately made it colorful, graphical, yellow, user green interface. So it's actually the interface that we are, when you talk about UI/UX, most of UI/UX people are going to be designing this graphical user interface. Nobody's going to be designing UI/UX for command line interface. I'm going to tell you the reason in a bit. So graphical user interface, that's where you use your mouse, you click, you right click, all those mouse actions, clicking, right clicking, top clicking, you are doing it on a GUI. GUI is the easiest to use. But ladies and gentlemen, the first people that used system did not have access to a GUI. It was typing. There was no mouse, keyboard. So the first interaction with a computer is actually a command line, right? I'm going to tell you why command line is important, and that's where you distinguish the boys from the men. So there's another type of interface called CLI, command line interface. Okay, command line interface is an interface where you just give commands. Mouse does not work there. Okay, command enter, up, down, command enter. you know. That's what we are going to be doing in the next class. We are going to do a CLI. Why do I want to introduce people to CLI a bit? Because people are going to be writing, of course, some people that are software developers are going to start getting used to the line command line interfaces. Okay. Yeah. So the thing we are trying to do, okay, I hope that we are correct, is to make sure that before people start doing some of these things, let them just get the basics, because the basics actually means that in the next class, I'm not just going to jump into command line interface, see what you're going to be doing. I want to show you people that there's what they call, where is it? No, this is not this thing. I want to show you, sorry, I'm using the wrong slide. The one that is relevant to us, just hold on a bit. So I'll keep talking, Sean, until the thing comes up. So we need to, look at different we need to look at different okay, yeah. So give me a minute. Okay. All right. I've seen what I'm looking for. So look at the slide now. So next week, when we come next week, this is what we are going to be looking at. So you look at the command line. We're going to type some command here, and I'm going to answer the question, why do we even need command line in the first place when we have all these fanciful icons and everything? We're going to answer that question. We're going to look at it, how it was, do some commands. This is what I was looking at. So we are going to teach you people what is scripting, because if I enter scripting now, we have already gone almost 2 hours into this course. Going to confirm what is a script. You need to look at types of scripts. When you hear shell script, bash scripts, JavaScript, and all that, you need to look at what is a shell. Look at what is bash. We're going to look at it. Then we're going to look at virtualization, okay, hypervisors, OS machine. You need to understand, because now this is your pressure. A lot of us don't know how these things work. You have your computer hardware, you can have your OS, you can now install your virtual machine, and then do your guest OS, and then do your application. So this whole idea of virtualization before you start running your shell script might even help some people set it up. So this is what we are going to be discussing next week. So I want to stop. This is a good place to stop it, so that we can do command line, and from command line we can do some Linux. I'm not going to bore you with a lot of programming, but just show you some few things. Not all of you will become programmers, but some of you are definitely going to, if you want to become a system admin, if you want to become a DevOps person, back end, front end, you can't run away from terminals. So, ladies and gentlemen, I want to actually keep to time. Is 3:40, 3:54, and I have a meeting. I think I have to draw the curtain here. I hope this is all making sense. We are experimenting with DAIPODS in this particular cohort of uh, uh, CodeCamp. So thank you for giving me your audience. I don't know whether Mr. Ike is on the call. All right. So, is there any question? I've not actually been taking. Very interesting. I'm always running off. I think it was in the first class I took some questions. Yeah. Please, let's take some questions if there's any. If there's none, we can actually draw the curtain here and let everybody go. Somebody said thank you, sir. Makes sense. Yeah, yeah. It's small. We are not rushing anybody. I'm going to be taking my time. That's why it's just once in a week. So that if I do this thing 2 times, everybody, I will just kind of pack it or this thing. So you give time for us to kind of absorb and assimilate what you have done. Okay, so I'm not seeing any hand up yet. So thank you very much for joining the class. I'm sure those that are not here will be able to have the recording. I want everybody to have uh, um, a fruitful the rest of today's Wednesday. Yeah. So have a night rest. Good night, everybody, and thanks for attending this class. Yeah, thanks. I'm stopping sharing now. Stop recording.